new to you guys.
Is it easier or
And the first three, so we're gonna do 6.1 through 6.3, quiz, 6.3 through 6.4 through 6.6.
Quiz next Thursday?
And then quiz, what is wrong with my mask? I cannot speak.
The next Thursday, we have the AP.
It's not gonna be next Thursday, it'll be the
What?
next Tuesday.
Next Thursday, we have the AP US history test, just letting you know.
So don't miss 6.3.
So 6.3.
Here?
Yeah.
So I have to, who's gonna miss it?
And Lila.
okay, if we're gonna be fair, you're still gonna have the test on that day.
I'll still be
That's
here,
right.
Mr. On.
Yeah.
I'll still
There's
be
not
here.
gonna be a test on that.
You guys just make it up over the weekend.
That's 6.3.
Oh, 6.3, 6.3. So I'll go ahead and do the lecture, you guys can watch the video. Just to be fair, because Hunter said we need to be
Yeah,
fair.
I'll be
Hey, let's
here.
be unfair in this world now. It's time to be unfair.
All right, so here we go, let's go. We're on page 456, vectors in the plane. So vector is something that actually is new to you. So let's look at, can you tell me the difference between speed and velocity?
One is speed and one is velocity.
What's the difference?
Is it velocity per second or something? It's been a while. since
Where do
we
you
did
learn?
this.
Okay, the unit is meters per second, feet per second. The meters, the units are the same.
But isn't velocity moving or something? I remember.
They're
doing
both moving. They have to be moving to have speed,
it.
right?
No, but. That's been too long.
I
It's
was
a lot.
student director.
What's the difference between mass and weight?
Gravity.
Gravity. Okay,
Velocity
So-
and gravity.
so weight has gravity in it, right?
Yeah.
Okay, so mass is just a mass. Okay, so a mass, a piece of a rock that weighs 10 pounds of mass in the earth is going to weigh 10 pounds, it's going to be, it's going to have the same mass when it goes to the moon, right? It's going to have a different weight though, because the gravitational constant for the earth is different than the moon, right? You've heard this before. So when you see the clip of the Apollo 11 people bouncing around, right? You've seen that before, right? I hope.
Yes.
They're bouncing around because the gravitational force is 1/6 of what the earth is.
What is it, like,
Okay, so they, with the same amount of force, they can jump higher. That make sense? Because there's less force grabbing it down. So, mass has no direction.
Oh, I see.
Weight has direction. Weight always goes down, right? Because the earth is trying to pull you, right? The earth is trying to pull my pen, right? So it falls down, it never falls up. This is the old Isaac Newton apple under the tree. Remember that?
Yes.
Right? Okay. So speed has no direction. Velocity has direction.
I was good in there.
So speed is really the magnitude of the velocity, because velocity has not only the magnitude, but it has direction. So that's what a vector is. A vector is something that has a magnitude and a direction. Okay?
What's a segment?
So if it does not have direction, it is not a vector. And those things that are not a vector, we call a scalar.
Oh, yeah.
Okay, it's a scalar. Okay? Just, we're not going to talk that much about it, but it is a scalar. Okay, so it's vector versus scalar. So if I have a point here, this is what a vector, how a vector is denoted. I have a
Arrow.
head and a tail. Head and tail. So if I am going from x1, y1 to x2, y2, the vector, we'll call this A. The vector A is denoted like such. And it uses brackets that look like this. This is the first time you guys ever seen this. Okay, and the vector is okay. So you're going to subtract the x2 from the subtract x2 minus x1, y2 minus y1, and that's the vector. Okay. So let's say that I had, this was, I don't know, 1 and 2. This guy is 4 and 5. So vector A would be 4 minus 1, which is 3. 5 minus 2, which is 3. And this is what the vector is. Okay. So it is possible, let's say I had something that went from here. This was A. And I have something that went from 3 to 3, and this is B. What is my B vector? Huh? Because this is 0, 0, right? Can you see that? So in other words, A and B are the same vector. They have the same magnitude, same direction. What would be the magnitude of this? If I asked you what was the magnitude of this, what would your guess be?
3, 3.
No, that's the,
3.
so it'd be the magnitude of this, the length of this, right? So I'm going 3 and 3, right? So what would the magnitude be?
1.
Does this make sense to you?
Isn't it minus
Plus, plus, plus.
the magnitude?
So I'm looking at the magnitudes here. The magnitude is this thing squared plus this thing squared, square rooted. Okay, so it would be square root of 9 plus 9, 18, 3 root 2. And that is the definition of the magnitude of a vector. Okay. Let's go to the bottom of page 456, blue box. Two-dimensional vector V is an ordered pair of real numbers denoted component form, blah, 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 component form, blah, blah. Standard representation of it is the blah, 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 blah. 0, 0 is called the zero vector. Okay. Page 457, head minus tail rule for vectors. If an arrow has an initial point and a terminal point, that, again, head, tail. So it's head minus the tail, right? So that's why the head minus the tail rule. Woo-hoo-hoo. Head minus the red tail, okay? All right. Flip the page. Go to page 458. There's another blue box. Magnitude or length of a vector. Okay. Magnitude. Okay, we talked about that. We talked about that, right? So let's do example 1 and 2. You don't want to skip those. Do those. Example 1, show that the arrow from blah, blah, blah is equal to the arrow blah, blah, blah. So I have a vector, example 1, RS, okay, RS. So S is -1 minus -4. And then I have 6 minus 2. What? Kind of, where'd that come from? Right? What will be the magnitude of that? In your head? 9 plus 16, 25, 5, right? It would be 5. Everybody get that? Okay. So that was RS. The other one was PQ. Q. So 5 minus 2.
Which will be the same thing.
Well, it should be. That's what they want us to prove that, right? 3 minus 1, 3, 4. So it's same, again, same vector, okay? Example number 2. Find the magnitude of the vector where that and that. So on this one, we're still doing PQ. PQ vector. P is -3. So it's -5 minus -3. And then I have 2 minus 4. -2, -2. So the magnitude of PQ is going to be square root of this squared plus this squared. Okay, so we're good with that. Vector operations. Bottom of page 458. Read the blue box there. How you add vectors, how you subtract vectors, how you multiply vectors. Any questions there? If not, run straight into example number 3. U is -1 and 3. V 4, 7. 1. They want us to find U plus V. U plus V. Add this to this, I get 3. Add this to this, I get 10. 2. 3U. 3U is nothing more than take this and multiply it by 3. Number 3, 2U minus V. 2U minus V. So 2 times this is -2. Minus 4 is -6. 2 times this is 6. Minus that is 1. Okay, so that's that. Unit vectors. Unit vector is a vector that has a magnitude of 1. Okay? Anybody give me an example of a vector that has a magnitude of 1?
1, 1.
1, 1? I don't think so.
No.
What?
2, -1. No.
2 and -1? I don't think so.
-3, 2.
Huh?
-3, 2.
1, 0. I have a winner. 1, 0, right? If I had 1, 0, right, the magnitude of this is 1 squared, 0 squared, 1. Good. Anything else?
-3, 2.
-3, 2? I don't think so.
Yeah.
-3, 2. This will be 9 plus 4 square root of 13. That's not it.
Oh.
The other way.
How about this?
I think the book lied to us.
That's what I don't want to see.
I know, that's what I'm thinking.
I'm good. I'm good. Wait, is that the weird thing?
If I square this, I get 1/2. If I square this, I get 1/2.
Oh, that's crazy, Mr. Ron. It's almost like, wow.
I don't
I don't
like
think we didn't need that.
You didn't need that? You didn't need to see that?
Crazy.
Okay, so let's go back to what Hunter
I
said.
like the 1 and 0.
And if I have this, okay, so we'll call this A. what is the magnitude of A? We just found out what it was, right? What was the magnitude of A?
9 plus 4.
Square root of 13, correct?
Yes.
What if I had this vector, divided it by this?
Oh, then it becomes fractions.
So it becomes fractions, right? So when I get this,
Squares and fractions. Then you have to reverse it.
right? So basically I'm doing this because I'm dividing it by that, right?
That's a lot of work.
So now let's go and square this. What do I get? 13 over 9. I square this, I get, oh, look at this. Whoa.
Then why do we do it?
So any vector, if I take any vector and divide it by its magnitude, it's going to be a unit vector. Okay? So if you go to page, it doesn't say that really. Where does it say that?
With velocity.
So if you go to bottom of page 459, a vector u with a magnitude of that is a unit vector. If the vector is not a zero vector, then the vector, so v vector divided by its magnitude is a unit vector, okay? That's what we're trying to find. So finding a unit vector, oh, well, look at this. Example number 4 is already done.
Wow, I wonder how you do that.
How'd you do that, Hunter? Did you look ahead?
Never.
Okay, so that's just what we did. That's what we just did, right? Now, there are a couple of special unit vectors, and one of them, Brooklyn was kind enough to tell us, and it was 1, 0.
I just figured,
Okay, and the other one is 0, 1.
Where did Brooklyn see that?
I didn't see it.
Okay, and
Oh, he did see it.
Oh, I did.
this is normally
Wow, Brooklyn.
called
It's common
I.
sense.
This is I, and this is J.
What?
Okay, I and J, they're called standard unit vectors. Okay, so the thing is this, what I can do is if I had a vector, let's say I had a vector was again -3 and 2, I can actually make this, I can denote this as
No, that makes sense.
think about it, right? 3, 1, 0 plus 2, 0, 1. If I do x, I get 3, 0. So I get, I'm just -3, I'm sorry, negative, right? Negative, right?
That worked.
And then there's 0 here, and then I have 2, I have 0 here, 2. You see how that works?
That works for everyone.
So it allows me to write this in this form. The standard unit vectors do. Okay, so that's where we use them, okay? There's a different way of writing the same thing. Okay, let's do one more thing. Direction angles, If V, so we're in the purple box, wall box, I guess, on the bottom.
You always bring it.
Okay, so it says, if V has a direction angle theta, the components of V can compute it using the formula. In other words, if I have a vector V and this is theta, okay, this guy here is what? V, whatever the magnitude was, right? And it's gonna be the cosine of that, right? Cosine theta. Whereas this guy up here is going to be the V magnitude, because this is the magnitude of V sine theta. So in other words, I can rewrite this as so basically this is what we call a decomposition. We're decomposing one vector in its x direction and its y direction. Right? Okay. So that's that, that's that. Let's do just example 5 and then we'll take a rest. Example 5. Find the components of vector v with the angle 115 and magnitude 6. Well, that's pretty simple, right? So it's going to be 6 cosine 115, 6 sine. That's it. And if you do, yeah, I'm not going to do that. Okay? Right? It was because it's a v, the magnitude, like the magnitude was given to us as 6. The angle was given as 115, cosine 115, sine 115. Okay? And we will do 6 when we come back. So let's go ahead and make a stop here.